Hey guys, back with you again for day 12. We're taking a look at sector area. First thing we have to figure out, we already knew what an arc was, but we may not know what a sector is. So a sector is a part of the circle that's bounded by the arc and two radii. Oh. Here's a radii, here's a radius, here's a radius, here's an arc. This piece right here is called a sector. Now, a sector is two-dimensional, whereas an arc length was one-dimensional, right? In your head, the way I think about a sector is it's like a piece of pizza. So next time you guys have a family pizza night, or you're having pizza with your friends when this stupid virus thing is done, don't ask for a slice of pizza. Ask your friend or family for a sector of pizza. Or how many sectors would you like? You may get some laughs from people who know what they're talking about. But it'll be funny. And again, sectors can be like a piece of pizza sized, right? It could be the shaded part here. Or we could think of this whole side here as a sector, right? The like Pac-Man part. That would also be a sector, right? And what we're working on is finding the area of sectors. Hopefully what will be easy for you to see is this relates really nice to Thursday's video, because obviously this sector area is going to relate to the area of the circle. And once again, it's just going to be a fraction of that area, and the area will be related to theta, the central angle. So here's how we find the sector area. So I want to find the area of this sector here. And I know that this sector has a central angle of theta and a radius of r. All I have to do is remember the formula for the area of a circle. And just as a reminder, area of the circle equals pi r squared. So a sector area then is just a fraction of the area of the circle. And that fraction is our central angle over 360. So this formula looks very similar to our arc length formula. We're still seeing this theta over 360. But instead of seeing 2 pi r, which is circumference, we're seeing pi r squared, which is circle area. So a sector area is just a fraction of the circle. If you think about having a pizza, let's say you cut a pizza into 6 equal slices. What's the area of one of those slices, one of those sectors? Well, it would just be 1/6 of the area of the whole pizza. Okay? And that central angle would have been 60 over 360. Okay, let's do some examples quick. Okay. So I want to find the area of this sector right here. Find the sector area. Okay. So what I'm going to do is I'm going to use my formula for sector area. And that sector area is just going to be equal to, right? Here my sector area is unknown, so that'll stay as sector area. Then we'll do 30 over 360 times, and now it's going to be pi r squared. So it's going to be pi 8 squared. And once again, I can do this by hand and reduce this thing, or I can use a calculator to make it easier on you if you want. So again, I'm going to type in everything. Oops, my fraction bar. I'm going to do 30 over 360. I'm going to type in everything except for the pi. So instead of writing pi 8 squared, I'm just going to write 8 squared. Or if you know 8 squared is 64, just write 64. And what I come out with is 16 over 3. Now I know that I didn't include the pi on my calculator because it was going to make it, pi is irrational, it's going to make a nasty decimal, right? I can just go back here and say, okay, so my answer is 16 thirds. Pi. Don't forget the pi, and don't forget the unit. Our units are always square units here because we're talking about area. Once again, sometimes they'll come out to be nice numbers, sometimes they'll come out to be fractions, but either way, they're always going to come out right. Okay. And again, you could do that by hand. 30 over 360. I know the zeros would cancel. 3 over 36. I know both of those are divided by 3. So it'd be 1 over 12 times 64 pi. So that would give me 64 over 12. But I know 64 and 12 both divide by what? Well, they both divide by 4. 12 divided by 4 is 3. 64 divided by 4 is 16. And that's where I get my 16 over 3 pi. So try some by hand, try some with the calculator. Be comfortable both ways. Just make sure we can get it right. Okay, let's try another example. Now you might be saying, Mr. Hartz, you forgot to put in the central angle. But take a look. Notice that that is a diameter. What would that central angle be? You saw one of these yesterday as well. Well, if this is a diameter, it's half of the circle. This central angle would be 180 degrees. So my sector area then is going to be 180 over 360. We should know right away that that's also half of the circle. Again, I have to do pi r squared. Here's where you need to be careful. I never gave you the radius. I gave you the diameter is 14. Right away in your head, you got to know, oh, that means radius equals 7. Okay. And doing this one, I know 7 squared is 49. Half of 49, it doesn't divide nicely, so I'll leave it as 49 over 2 pi inches squared. As my final answer. Okay. Let's try one more example. Okay, so here's the problem. A circle has a sector area of 16 pi centimeters squared and a central angle of 90 degrees. Find the radius. Okay, so I know this is a sector area problem, but I actually know the sector area, right? It tells me the sector area is 16 pi centimeters squared, and it tells me the central angle. It's asking me to find the radius. I'm using that same equation, okay, but now my unknown is going to be the radius. My radius is unknown. So again, when you just think about the equation here, I know sector area equals theta over 360 times pi r squared. I should be able to plug in for everything except for r. So let's go ahead and do that. 16 pi, remember, is the sector area, so that's going to go in here. 90 degrees is my central angle, so that's going to go in here. And r squared is my unknown. Okay. First thing I'm going to do here is get rid of those pi's. I have a pi on both sides. Okay. 90 over 360, I know is 1/4. So I'm going to have 16 equals 1/4 r squared. And I want to get r. I want to figure out what r is. So I want to get rid of this fraction. So I'm going to multiply both sides by 4. And I'm going to get 64 equals r squared. Okay. Now, what do you think my last move is going to be? Well, if r squared equals 64, then I can do the square root on both sides, and I get r equals 8. And my 8 should be in the unit centimeters. All right, that's it for this one. Enjoy the problems. Do well. Talk to you guys later. Stay safe. Bye.